Yeah, good evening. We'll continue the discussion. Earlier video abruptly ended because of time restriction of 15 minutes. Anyway, we try to go back to the presentation. Uh, so we have completed the discussion on cation exchange. Okay, now the waterlogging and soil salinity. Here, how this water logging is really affecting the soil salinity, that discussion we will have. It was observed that the salt problem in high water table areas is mostly governed by the amount and intensity of rainfall. Naturally, because rainfall is the primary source of water, either surface or ground, and along with it carries the surface water or groundwater, the salts. Okay, in the monsoon season, when water table rises and comes near the surface, the land is temporarily waterlogged, due to which salinity is reduced. In fact, during the monsoon season, when this water table is raised, okay, comes almost near to the surface, and land is temporarily waterlogged, due to which salinity is reduced because of dilution. But after the rains and with the onset of winter, okay, after the rains or with the onset of winter, what is happening? Water is lost by evaporation and salts are deposited on the surface. See, when the monsoon is over and winter is set in and all the water goes down, that temporarily built up water table, and exposed to evaporation of the soil, and then this slowly the salts crops up on the surface of the soil. During the cropping period of winter crop, such lands are irrigated and the salts present in the soil profile move up and down. Again, what will happen during the Rabi season? You will be irrigating. So again you are adding water, means this some salts goes down. And this is a problem for moving up and down. Like that, overall, most of these soils are enriched with some kind of, salts only. Okay, consequently, what is happening? The total soil salinity is controlled by the period of waterlogging, water transmission characteristics of the soil, the salt content of the groundwater, and the evaporative conditions of the region. So these are the many things that all depends upon the salinity of the soil, particularly during the waterlogging conditions. See, it all depends upon how much period it is waterlogging, and then water transmission characteristics through the soil. Then, of course, the salt content of the groundwater when you are doing irrigation during Rabi season. Normally, in Rabi season, we do irrigation with the groundwater. So, and then evaporative conditions. If it's arid region, then definitely the salts are more accumulated. So, definitely waterlogging contributes to the salt problems several times, definitely. Topography of the land also modifies the ultimate soil salinity. If the topography is somewhat more slopey, then it does not matter. But if it is very plain land, then definitely waterlogging will enhance the soil salinity. Okay, then let us go reclamation and management of salt affected soils. Okay, so far you have seen the salts accumulation due to various reasons, its origin, its transportation to the low-lying areas, and then waterlogging. All these things contribute. But is there any way that we can reclaim these salt affected soils? So that is we discuss now. The process and practices involved in bringing saline and alkali soils into productive condition are known as reclamation measures. So when we are bringing back that soil to its original condition by freeing themselves from salts, is known as reclamation of the soils. The efficiency of any reclamation measure depends on the proper diagnosis of the problem of soils. Hence, before any reclamation procedure is applied, it is essential to determine the following. So, first of all, you should diagnose properly. What are its various characteristics and all. Without diagnosis, you cannot have a medicine. So, that is why What are the things you should do during diagnosis of the soils? Number one, the nature of the soil, whether it is alkaline or alkali, saline or saline alkali, and so on. And then degree of salinity or alkalinity in the soil profile. It can be, we can compute this SAR ratio, percent sodium, and so on, many things. Quality of water available for leaching out salts and the reaction products. For invariably, you have to have some fresh water to leach out these salts. So that availability of fresh water and its quality is very important. Again, that water again contains some sodium and all, then it's not so effective. Okay. Then, of course, the very important one is the drainage characteristics of the soil. If you cannot have any drainage, it is just impossible to drive away the salts from the soil. Okay, then the topography of the land, usually with a slope and all, and the presence of any hard pan of lime or clay in the soil strata. So, in the subsoil, if you have some kind of hard pan, then it is impossible to drive those salts below the root zone. So laterally only this soil has to be drained out. Okay, so let us go further. Reclamation procedures. What are the various procedures available? Reclamation of a soil on a temporary basis can be done like this. Not all soils very much gets fully saline. There are signs of starting salinization and all. So you can start these temporary measures and get away with those salt problems. What is that? First of all, removing the salt crust from the surface of the soil. Whatever you see, earlier I have just explained, some like a thin layer of whitish material appearance. So you can remove that crust almost from the soil and then do your business as usual. Then ploughing the salt surface crust deep into the soil. You can have a disc ploughing with the tractor and then completely overturn this crust of the salt below the soil. So like that, neutralizing the effects of the certain salts by adding certain other salts or chemicals, whatever it is. So there are of course some temporary measures. You need not immediately jump into the permanent measures, but when you are observing your soils, whenever you have any kind of indication that it is being inflicted with some kind of salt problems, you can take these measures. Then, however, the permanent reclamation can be obtained by the following procedures. What is that permanent one? Lowering of water table. First of all, the regional water table or even the local water table must be lower than just below the 2 meters, even more than that. And then only it is possible to arrest these waterlogging conditions or salt problems. How do we done? This is again a lot of technology is there, pumping of the water. We have discussed in groundwater, like mixing of surface water and groundwater. That is called conjunctive use. So there, of course, there is a different chapter altogether. Then improving infiltration rate of the soil. You can see even we have also done during our school days, even where there is a high clay soil, we used to have to add the silt accumulated from the from the tank beds. We used to bring the tank bed soil. Nowadays also in Mission Kakatiya and all these tank bed soils, it is also nutrient also. So they can be added to the clay soils. Then infiltration and drainage characteristics of the soil can be improved. Leaching of salts in saline soils and providing adequate subsurface drainage. Of course, leaching techniques are there. We are going to discuss again. And then providing adequate subsurface drainage. This is all along that we have been advocating. If you do not have a proper drainage for irrigated agriculture, it is impossible to maintain that for a quite long. Okay. So replacing exchangeable Na by Ca salts and removing the replaced products and suitable management practices. See, naturally, ultimately, who is the culprit? Our villain is the sodium. Of course, even for our body also, villain is the sodium. The more salts you take, then you will be diagnosed with high BP and so on. Similarly, for soils also, when the soil is enriched with sodium, then it is a problem. So, Ca should be replaceable. That is how you can add gypsum and all these things. We will discuss that. So all these suitable management techniques you can practice, and of course some more management modern techniques are also there. Anything, the fundamentals are like this. Basically, you have to remove those salts either by leaching in the case of saline soils or by adding some chemicals or gypsum in the case of sodic soils or alkaline soils. Let us go those techniques now. So the reclamation of saline soils. It's very simple. The reclamation of saline soil depends on the efficiency of removal of salts from the upper to lower layers and is thus relatively simple if drainage is not restricted. If you are having a proper drainage within the subsoil, I don't think it is a big difficult, because you have to wash that soil very frequently with fresh water, that's all. But water should be available. That is always a major impediment for arid and semi-arid regions. So the simplest procedure is to flood the field after making ridges or levees at the boundaries. So you make plots, you fill that plot with fresh water heavily. Then the movement of water through the soil profile will occur. And then the water carry dissolved salts into the lower layers below the root zone. So vertically you are pushing it down. These salts you are pushing it down vertically below the root zone. So that is a technique. These salts are drained away if adequate subsurface drain is provided. So below the this root zone, if you provide some kind of tile drain or some other thing, then you can remove completely from your field. That is the best procedure. The quantity of water needed for leaching depends mainly on the severity of the salinity problem and the depth and degree of the reclamation design. So of course, how much water you need and all, it all site specific and then land specific and then situation specific. You can just determine that those things on your field experience. Okay, the efficiency of the reclamation per unit volume of water will be maximum with good water. So while you are reclaiming, you must use good water. Again, you cannot use some water which is dominated by some kind of salinity. So these are the very important points. We'll go quickly with this picture. See, this is the how the root zone. These are the salts accumulated, and then water is placed. This water moves and then to this drainage and then removed. Okay, this is a very simple picture, easily understandable. Irrigation water, salts, and then excess water is removed through this drainage outlet. Okay, then reclamation of alkali soil. See, reclamation of alkali soil is more difficult than saline soil because alkali soils have a very low permeability. That's the very beginning where I told, sodium reacts with soil and reduces its permeability. In the case of alkali, it is much more. So they require the replacement of excessive exchangeable sodium by calcium. So somehow or other, you must see that you cannot wash the soils here in this case, like in the salinity. In the case of alkali soils, you must replace that sodium by calcium. That is the only method you can adapt to. It is necessary that the replaced ions are leached down to lower layers. Even that replaced ions also, there was ions which are detached from the soil. You can move down, leach to lower down the layers, but it's very difficult process. The improvement of the soil tilt is slow in alkali soils. Even in the case of saline soils, you can see the improvement within 1 or 2 washes or 3 washes. But whereas in the case of this alkali soil, it is not so seen immediately. Excessive exchangeable sodium can be replaced by any cheap source of calcium and magnesium salts such as calcium chloride, magnesium chloride, and gypsum. But what is happening? This calcium and magnesium chlorides are somewhat not so cheap. They are cost prohibitive. So that is why gypsum is a major one which we use. So that's what is written here. Soluble calcium and magnesium salts are suitable for the reclamation of alkali soils. Of these salts, calcium and magnesium chlorides are very quick in reaction but are too expensive. So calcium and magnesium soils are expensive, that method. But what you can see on a commercial basis, reclamation process with this calcium and magnesium is not possible. However, gypsum, by virtue of its low solubility and low cost, is quite suitable and is widely used. So gypsum is cheap, and you can buy gypsum bags like cement bags. You can buy gypsum bags also. You can buy, and it is available in the market. You can use, of course, the method of adding and the quantity, you can decide with the kind of alkalinity and so on. In India, large deposits of gypsum are found in Rajasthan, of course. In calcareous alkali soils, some acid forming reagents can also bring about reclamation by dissolving calcium carbonate and creating acidity. So you treat first with calcium carbonate and repeat the procedure. I think this will take care of the reclamation of the soils. I will stop here, and then this completes your salt problems for irrigation, okay, in the agriculture. Thank you very much.